Okay, so part 2 of day 4 is going to be split into, funny enough, 4 parts. So I know it's going to look like we have a lot of questions today, but really we're splitting these questions into 4 parts. And some of these parts I'm going to let you guys kind of work on, but others I obviously want to help you in any way I can as well. And so like for our first part here, you see we've got part 1, which is connected. It actually is connected this time. Part 2, which is also connected, about midpoint and about this line segment. Part 3, which is not connected. These are just random. They're not connected. And then part 4, which is connected to this drawing of line segments and angles and rays. And so really, guys, we're just splitting this up into 4 parts today. And if you think of it that way, today this part is going to go very, very quickly. So I wanted to give you guys a chance to look over. And again, here's the thing. If you want to work ahead, yes, you absolutely can work ahead before we do any of this. And some of these I am going to let you guys work ahead. But like 34 through 39, I'm going to work with you guys. But if you want to go ahead and give it a shot, as long as you do it in pencil, you can go for it. Absolutely. But let's go ahead and get into it, guys. I don't want to waste any more of your time. So we see over here we've got some angles, and we're told AOE and COD are vertical angles. How can we say that? Well, if it's just a good old statement, then we're talking definition of vertical angles. Now, check it out. If AOE and COD are vertical angles, then they are congruent. They're equal to each other. Well, we got math at the ends here, so we know it's not a converse. And if you think back, if we go back, let me just break my phone real quick. Vertical angle theorem says that if 2 angles are vertical angles, their measures are going to be congruent. So we're talking vertical angle theorem. And do you see how these two are kind of connected? 34 and 35, they kind of went hand in hand here. Well, check it out. We're switching it up a little bit. Now, we're going AOC and COD. And these two, 36 and 37, are going to be connected. So now we're switching from vertical angles, which we were talking about, to now we're talking about AOC and COD, linear pairs and supplementary. So notice that these two are connected now. So if AOC is and COD are a linear pair, how can we state that? What lets us state that? Well, that's going to be a straight up definition of a linear pair. But then from there we can then say, okay, well, if they're a linear pair, then they're going to be supplementary. And that's where that postulate comes in. We're talking the linear pair postulate. Okay. Usually if you see the definition of a linear pair, these two usually are together. And then finally, check it out. We switch over to talking about BOC and COD before kind of heading back to AOC and COD, which we were talking about up here. But before we get into, again, supplementary action, let's see. We got BOC plus COD equals BOD. So BOC, part, looks like this is a part plus part equals the whole kind of action going on here. So if that's, but we're talking about angles. So if we're talking about angles, that is angle, add, post. So these last two aren't really connected. And then finally we've got AOC plus angle COD. Now wait a minute, we got math. We got math to start this one. Ooh, so I'm thinking we're talking about a converse here. Well, and what are we talking about a converse of? Well, if these add up to 180, then those two are supplementary. So we're talking about the converse of the definition. I don't know why I put two F's of supplementary. Converse definition of supplementary. Okay. Now that we've done one together, I'm going to give you guys a chance to fly free here. Now, once you get down to here, I think you guys are really going to like this. I think you're going to thrive on 45 to 49. I feel really good about that. But I want us to try 40 through 49. And it's okay if you get a little confused on some of these. Remember to look for if math is first. Also, remember what we know about 1/2 here. So don't forget about what 1/2 means. That'll be my little spoiler for you. Which one that tells us we're dealing with if we're seeing halves. So guys, you can go ahead and try 40 through 49. Let's see what you guys got here. So number 40, S is the midpoint of RT. We're just saying straight up S is. How can we say that? Well, that's just a declaration based off the definition of a midpoint. Now, if S is the midpoint of RT, then RS equals ST, so math is coming second, so we know we don't have a converse. In fact, I'm pretty sure this is just saying the same thing that the previous step said. So these two are connected here. These are both just the definition of a midpoint. But here's the thing. What if we switch it? Now the math switches around to first, and the declaration of it being a midpoint comes second. We're talking converse definition of a midpoint. So we're saying, hey, if RS equals ST, then S is going to be the midpoint based off our math. Well, if that's the case, if RS is equal to 1/2 of RT, then S is the midpoint. So we're saying, okay, now we can say then that RS is going to be 1/2 of the whole. If we're dealing with the 1/2, we know we're dealing with a theorem. And if the math is coming first, we know we got a converse, but it's not a converse of the definition. It's a converse of the midpoint theorem. If we're dealing with that 1/2, we're talking about the theorem here. And then we switch it. So we say, okay, let's bring the math to the back here, and we're saying, okay, if S is the midpoint RT, then ST equals 1/2 of RT. That is going to be, what are you guys thinking here? Well, now it's actually just the normal midpoint theorem. Then we switch gears. We're saying, okay, RS plus ST equals RT. So part plus part equals whole. We're talking seg-add post. And I'm going to let you guys take a look at the rest. You're going to notice that I've got one blank here. Where did all this come from? Check it out. RS became 6x plus 8. ST became 6x plus 8. And we knew RT was 52. We used substitution. 45 led into 46. So then we distribute, subtract, and divide. So hopefully you guys are feeling really good on that one. And on to the last page. And as we're getting ready to go to the last page, just note that if that was 6x plus 8, that was 6x plus 8. So that's where ST was able to come from, because we knew this piece and this piece were the same based off what we established up here. Now to page 4, guys. Now we're going to come back to this top section. These 9 problems right here. We're going to come back to that. And I'm going to let you guys try that on your own. But before we do that, I want to do this last section together. And if you want to kind of work a little bit ahead and see if you can do 59 through 65, I'm talking to Dan, Lindsay. I'm trying to think of some other people who like to work ahead. Justin, etc. You know, my peeps who like to work ahead a little bit. You guys are more than welcome to do so. But if you'd like to make sure you're working through with me, that is okay too. So we're going to be using this piece down here. And let's just get started, guys. So if because again, I don't want to take up too much of your time. If segment AD is perpendicular to ray OB, then we've got a right angle. AOB is going to be a right angle. We see that right here. Okay, so we're talking about perpendicular and that leading to it being a right angle. Well, if I look back at my definitions, check out the definition of perpendicular lines. If two lines, rays, or segments are perpendicular, then they form right angles. Pretty sure that's what this is saying right here. This segment is perpendicular, so we got a right angle. So we're straight up talking the definition, which again, that symbol means perpendicular. We got the definition of the perpendicular lines. And if that's the case, check it out. We switch our subject, since we brought up right angles, we switch to right angles. The math is second, so we got words, then math, which means we got a regular definition here. And that's going to be the definition of our subject, a right angle. And check out what happens here. We switch it up. The conclusion becomes a hypothesis. Hypothesis becomes a conclusion. We switched it here. So this is obviously going to be the converse definition of a right triangle, of a right angle. So we're saying, hey, if this is a right angle, we know it's going to be 90 degrees. So that's what we've been able to establish so far. And here's where we're actually going to start to be able to describe the rest of this picture here. So you're going to notice section 59 through 62 are connected, talking about right angles and things like that. But then, here in a minute, I'm going to let you guys try 63, 64, which are connected, and then 65. But let's finish with 62 here. So if AOB is a right angle, then the segment AD is perpendicular to ray OB. So we're talking perp. We're back to perpendicular again. And actually, look back at this top here. We said if AD is perpendicular, then AOB is a right angle. Now we're saying if AOB is a right angle, then segment AD is perpendicular. We kind of switched that, didn't we? Well, if we switch the conclusion and hype, we're talking converse definition of perpendicular lines. So we switched it up a little bit here. So we can say these are perpendicular. So in other words, that's going to be perpendicular, so which means right angle. And so I'm going to let you guys see what we can find out about 63 and 64. And as you do so, keep in mind of what we have established here. We said AOB is 90 degrees. And now we're going to be getting into AOC and DOE being vertical angles. So give me your best shot here. Try 63, 64, and 65. So we see here, we got a straight statement, AOC and DOE are vertical angles based off the definition. And if they are vertical angles, then here's our math. AOC should equal DOE. We're talking vertical angle theorem because of that congruency statement. And then we're saying part plus part should equal whole. AOE, this part, plus AOC, this part, should equal this whole straight line, the whole, which is 180 degrees. And so guys, I'm going to finish by very quickly letting you guys take your time and work on 50 through 58, kind of as a contradiction there. And when you're ready, you can unfreeze, and we will look over. And again, these are not connected. We'll look back and see how you guys are feeling on these properties. So you guys can go ahead. Check it out, guys. I put most of these down for you, and in fact, I included some that we get kind of tripped up on right next to each other. Like look at 50 and 51. 50 is transitive because we're saying if angle 7 is really 4x plus 9, and angle 7 is really 90, then let's cut out the middleman. And really, 4x plus 9 can be set equal to 90. You see how we take one whole side and set it equal to the other whole side here. We're not taking a part and putting it into the busy side of the equation. We're saying one total equals another total. Look at the difference for 51 though. If 6x plus b, so b's included in here, is equal to one side, 24, and b is really 9, we can substitute 9 into this piece right here, b, and say that 6x plus 9 is equal to 24. That's substitution. Of course, AB equaling itself is reflexive. Here too that we get confused. I know I talked about this on part 1. If we're just saying that if you take the left side and flip it and put it on the right side, that it's still going to be equal to each other, right? X plus 1 is still going to be equal to if you flip that around and did 1 plus x. Whereas symmetric is saying, hey, if you have this whole equation, and we take the right side of this equation, move it to the left, and we take the left side of this equation and move it to the right, it's still equal to each other. That's symmetric. And then the one I was worried about is 55 and 56. I almost made this mistake, guys. If x plus 1 equals 8, so that's our total, and our total is really equal to d, then we can say that let's cut out these totals and set one side equal to the other side. We can say that if x plus 1 equals 8, and 8 is really equal to the variable d, then x plus 1 is really just equal to d. That would be transitive. How about this one, though? If a piece, x plus a, is equal to 8, and we know a is really 1, then we can plug 1 in for a and say, well, then x plus 1 is going to equal 8. That would be substitution. So be very careful on that one, guys. And then finally, B is a midpoint of AZ, then, that should say then, ZB is equal to 1/2 AZ. Oh, we got the 1/2. Math is at the end, so it is a normal midpoint theorem. Check out last one, 58. Math first. If angle 1 plus angle 17 is 90, then those two angles are complementary. There's our subject. So we know we're dealing with complementary angles, but we put math first, so we're talking converse. And so, woo, you want to talk about a heavy day. But I'm so proud of you guys. If you have any questions, you know how to get in contact with me. And be on the lookout for day 5 on Sunday. It's a mini lesson. I'll be talking to you guys soon.